gas cylinders are installed in a room with electrical equipment, it is necessary to replace all electrical equipment in the room with Class 1, Division 2 equipment. The entire room is considered a Division 2 hazardous location due to the presence of flammable gas. Electrical equipment in Division 2 areas must be designed to prevent ignition of flammable vapors, gases, or dusts. If gas cylinders are located outside the room and only piping goes through, it is not necessary to replace the electrical equipment with Class 1, Division 2 equipment. However, the piping passing through the room creates a Division 2 hazardous location within a 3-foot radius of the piping. The area outside the 3-foot radius of piping is not considered a hazardous location. Considering general requirements for space designated as Class 1, Division 2, the panel board must be installed in a National Electrical Manufacturers Association NEMA 7 enclosure, which is explosion-proof. Conduit within the room should be threaded rigid steel to prevent the escape of flammable gas or vapors. All other electrical equipment, such as switches, outlets, and lighting fixtures, must also be Class 1, Division 2 rated. These requirements are based on the assumption that the gas being stored is considered a Class 1 flammable gas or vapor. If the gas is a Class 2 or Class 3 flammable gas, different requirements may apply. Consult the National Electrical Code (NEC) for specific guidance for each type of gas classification. Class 1 locations are those in which flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 is a location in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors can exist under normal operating conditions, or in which ignitable concentrations of such flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors may exist frequently because of repair or maintenance operations or because of leakage, or in which equipment is operated or processes are carried on of such a nature that equipment breakdown or faulty operations could result in the release of ignitable concentrations of flammable gases or vapors, and also could cause simultaneous failure of electrical equipment in a manner that would cause the electrical equipment to become a source of ignition. Division 2 is a location in which volatile flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors are handled, processed, or used, but in which the liquids, vapors, or gases will normally be confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquids are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or normal operation of the ventilating equipment, or that is adjacent to a Class 1, Division 1 location, and to which ignitable concentrations of flammable gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. For Class 1, Division 1 locations, equipment shall be identified for Class 1, Division 1 locations. For Class 1, Division 2 locations, equipment shall be identified for Class 1, Division 2 locations, or shall be of the totally enclosed type or be so constructed and installed that explosive or ignitable concentrations of the flammable gas have been prevented from entering the enclosure by positive pressure ventilation from a source of clean air, and effective safeguards against failure of the ventilation system are provided, or be submerged in oil or enclosed in a vault in a manner that complies with specified requirements. For Class 1, Division 2 locations, the temperature of any exposed surface shall not operate at a temperature in excess of the ignition temperature of the specific gas or vapor involved. Wiring methods in Class 1 locations shall comply with specific requirements. In Class 1, Division 1 locations, all wiring and equipment shall comply with specific installation methods. These include threaded rigid metal conduit, threaded steel intermediate metal conduit, or Type MI cable with fittings identified for the location. Boxes, fittings, and joints shall be explosion-proof. In Class 1, Division 2 locations, wiring methods shall comply with specific installation methods. These include threaded rigid metal conduit, threaded steel intermediate metal conduit, enclosed casketed busways Type PLTC cable in accordance with Article 727. Type ITC cable as permitted in Article 727. Type MI, MC, MV, TC, or TCER cable with fittings identified for the location or other suitable material. For Class 1, Division 2 locations, where provision must be made for limited flexibility, such as at motor terminals, flexible fittings identified for the location shall be used. Extra precautions must be taken to ensure electrical safety when gas cylinders are present in a room. Firstly, identify the type of gas being stored to determine if it is a Class 1, Class 2, or Class 3 flammable gas. Different requirements apply based on the gas classification. Secondly, determine the extent of the hazardous location. If the gas cylinders are inside the room, the entire room may be classified as a Class 1, Division 2 hazardous location. If the cylinders are outside and only the piping goes through the room, a 3-foot radius around the piping may be classified as a Class 1, Division 2 hazardous location. Thirdly, use equipment approved for the hazardous location. Ensure that all electrical equipment, including panel boards, conduit, switches, outlets, and lighting fixtures, is rated for Class 1, Division 2 locations. Panel boards should be installed in NEMA 7 enclosures. Fourthly, use proper wiring methods. Conduit within the hazardous location should be threaded rigid steel to prevent the escape of flammable gas or vapors. Fifthly, control ignition sources. Electrical equipment in hazardous locations must be designed to prevent ignition of flammable vapors, gases, or dusts. Avoid using equipment that produces sparks or high temperatures. Sixthly, follow National Electrical Code (NEC) guidelines. Consult the NEC for specific guidance on electrical installations in hazardous locations. The NEC provides detailed requirements for equipment, wiring, and other safety measures. It is important to note that the requirements provided here are based on the assumption that the gas being stored is considered a Class 1 flammable gas or vapor. If the gas is a Class 2 or Class 3 flammable gas, different requirements may apply. Always consult the NEC for specific guidance based on the type of gas being stored and the specific conditions of the installation. The NEC provides detailed requirements for electrical installations in hazardous locations, including specific requirements for equipment, wiring, and other safety measures. Understanding the difference between Class 1, Division 1, and Division 2 locations is crucial for ensuring electrical safety in the areas where flammable gases or vapors may be present. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where ignitable concentrations of flammable gases or vapors can exist under normal operating conditions, frequently due to repair or maintenance, or where equipment failure could result in the release of ignitable concentrations and cause simultaneous electrical failure leading to ignition. Division 2 locations are those where volatile flammable gases or vapors are handled, processed, or used, but are normally confined within closed containers or systems and can only escape in case of accidental rupture or breakdown, or where ignitable concentrations are normally prevented by positive mechanical ventilation, or that are adjacent to a Class 1, Division 1 location and to which ignitable concentrations might occasionally be communicated. In Class 1, Division 1 locations, all wiring and equipment must comply with specific installation methods, such as threaded rigid metal conduit, threaded steel intermediate metal conduit, or Type MI cable with fittings identified for the location. Boxes, fittings, and joints must be explosion-proof. In Class 1, Division 2 locations, wiring methods must comply with specific installation methods such as threaded rigid metal conduit, threaded steel intermediate metal conduit, enclosed gasketed busways, or certain types of cable with fittings identified for the location. Flexible fittings identified for the location must be used where provision must be made for limited flexibility, such as at motor terminals. The selection of appropriate electrical equipment for Class 1, Division 2 locations is critical to prevent ignition of flammable gases or vapors. Equipment must be identified for Class 1, Division 2 locations, or be of the totally enclosed type, or be so constructed and installed that explosive or ignitable concentrations are prevented from entering the enclosure by positive pressure ventilation, or be submerged in oil or enclosed in a vault in a manner that complies with specified requirements. The temperature of any exposed surface in a Class 1, Division 2 location must not exceed the ignition temperature of the specific gas or vapor involved. Proper ventilation is essential in Class 1, Division 2 locations to prevent the accumulation of flammable gases or vapors. Ventilation systems should be designed to provide adequate airflow to dilute and remove any potential ignitable concentrations. Effective safeguards against failure of the ventilation system must be provided. Regular inspections and maintenance are essential to ensure the continued safety of electrical equipment in hazardous locations. Inspections should be conducted to identify any signs of damage, wear, or deterioration, and maintenance should be performed to address any issues promptly. It is important to train personnel who work in or around hazardous locations on the potential hazards and the safety precautions that must be followed. Training should cover the proper use of electrical equipment, the importance of ventilation, and the procedures to follow in the event of a gas leak or other emergency. When installing gas cylinders in a room with electrical equipment, it is important to consider the potential for the formation of explosive or ignitable mixtures. The National Fire Protection Association, NFPA, provides guidance on the safe storage and handling of compressed gases, including requirements for ventilation, fire protection, and emergency response. The Compressed Gas Association, CGA, also provides information and resources on the safe handling of compressed gases. It is important to consult with qualified professionals such as electrical engineers and safety consultants to ensure that electrical installations in hazardous locations comply with all applicable codes and standards. These professionals can provide guidance on the selection of appropriate equipment, the design of ventilation systems, and the implementation of safety procedures. When evaluating the potential for a hazardous location, it is important to consider all potential sources of flammable gases or vapors, including leaks from gas cylinders, piping, and equipment. The extent of the hazardous location should be determined based on the potential for the formation of explosive or ignitable mixtures. It is important to document all aspects of the electrical installation in hazardous locations, including equipment specifications, wiring diagrams, and safety procedures. This documentation can be used for future reference and to facilitate inspections and maintenance. The NEC contains specific requirements for the use of flexible cords and cables in hazardous locations. Flexible cords and cables must be of a type approved for use in the specific hazardous location and must be installed in accordance with the NEC requirements. The NEC also contains specific requirements for the use of grounding and bonding in hazardous locations. Grounding and bonding are essential to prevent the accumulation of static electricity, which can be a source of ignition in hazardous locations. The use of intrinsically safe equipment can be an effective way to minimize the risk of ignition in hazardous locations. Intrinsically safe equipment is designed to limit the amount of energy available to ignite a flammable atmosphere. When selecting electrical equipment for hazardous locations, it is important to consider the temperature rating of the equipment. The temperature rating indicates the maximum surface temperature that the equipment will reach under normal operating conditions. The temperature rating must be below the ignition temperature of the flammable gas or vapor present in the hazardous location. The use of explosion-proof enclosures is a common method of protecting electrical equipment in hazardous locations. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding atmosphere. The NEC requires that all electrical equipment installed in hazardous locations be clearly marked with the appropriate class, division, and group designation. This marking indicates the type of hazardous atmosphere for which the equipment is approved. The NEC provides specific requirements for the installation of lighting fixtures in hazardous locations. Lighting fixtures must be of a type approved for use in the specific hazardous location and must be installed in accordance with the NEC requirements. The NEC also provides specific requirements for the installation of motors and generators in hazardous locations. Motors and generators must be of a type approved for use in the specific hazardous location and must be installed in accordance with the NEC requirements. The use of seals and barriers is an important method of preventing the migration of flammable gases or vapors from one area to another. Seals and barriers are typically installed in conduit runs and around equipment enclosures. The NEC contains specific requirements for the installation of control equipment in hazardous locations. Control equipment must be of a type approved for use in a specific hazardous location and must be installed in accordance with the NEC requirements. It is important to stay up to date on the latest codes and standards related to electrical safety in hazardous locations. The NEC is updated every 3 years, and it is important to be aware of any changes that may affect electrical installations in hazardous locations. The installation of gas cylinders in a room with electrical equipment presents a significant safety hazard if not properly addressed. By following the guidelines and requirements outlined in the NEC and other applicable codes and standards, it is possible to minimize the risk of explosion and ensure the safety of personnel and property.